In this video, we're going to go over section 2.3 from your textbook, which is an introduction to combinatorics. Combinatorics deals with counting. So we're going to talk about the fundamental principle of counting. I'll talk a little bit about it first, and then I'll show you the formal definition. The fundamental principle of counting allows us to determine the total number of possible outcomes when you have to make a series of decisions. Sometimes it's also called the multiplication principle, and you'll see why that is in just a few minutes. So we would use this fundamental principle of counting if we wanted to know how many possible outcomes there are when we have to make multiple decisions. If we're selecting an item, you can make selections either with replacement or without replacement. Now we'll talk more about each of those in just a second, but first let's look at the formal definition of the fundamental principle of counting. Here's the formal definition. It says the fundamental principle. So let's talk about what it means to select items with replacement. When you select items with replacement, that means that that same item can be selected more than once. So for example, after a specific item has been chosen, it's put back into the pool of future choices. So for example, imagine if maybe a teacher is selecting names out of a hat. So if you were selecting names with replacement, then you would pick a name and then you would put it back in the hat after you picked it. So that's with replacement. Selecting items without replacement means that the same item cannot be selected more than once. So after a specific item has been chosen, it is not replaced or not put back into the pool of future choices. So again, if a teacher was choosing names out of a hat, the teacher would choose the name and then it goes out of the hat. So it is not allowed to be chosen again. Let's look at an example of selecting items with replacement. Suppose that you open a checking account at a bank and you have to select a 4-digit personal identification number for a bank account. Personal identification number, that's your PIN. In this case, your digits are selected with replacement. So what that means is that you're allowed to choose the same number multiple times. So if you wanted to, you could go in and choose your PIN number to be like 1111. So the digits are selected with replacement. And here I've just detailed what that means. It says each time a specific digit is selected, the digit is put back into the pool of choices for the next selection. So let's suppose that let's look at an example where we're going to pretend like we're choosing our PIN number. Suppose that my bank uses a 4-digit PIN number. I know some banks now use a 6-digit PIN number or maybe more than that. All right, but let's just imagine that my bank uses a 4-digit PIN. How many different options are there for 4-digit PINs? All right, so we are going to follow what the fundamental principle of counting said. We're going to start by drawing our boxes for all of our decisions. So we have our first digit, our second digit, our third digit, and our fourth digit. Now we'll go back and we'll fill in these boxes with the number of choices that we have for each digit. So what can I choose for my first digit? I can choose any number between 0 and 9. So that's 10 choices. So if you count up how many numbers there are there's 10 choices. So I have 10 options for my first digit. What can I choose for my second digit? Once again, if you wanted to, you could choose the same exact number. So there are still those 10 choices. For my third digit, we also have 10 choices. And then for my fourth digit, I have 10 choices. Now, if you remember back, the fundamental principle of counting said that what I do now is I multiply all these numbers, and that's how many different options there are. So I'm going to multiply these. So 10 times 10 times 10 times 10 is 10,000. So there are 10,000 different options for 4-digit PINs. Now let's look at selecting items without replacement. Suppose that you're a basketball coach. You have 12 players. You need to select 5 players to start the game. In this case, your players are selected without replacement. So each time you select a player, their name is removed from the pool of choices for the next selection. So you can't have one person playing multiple positions. Alright, so let's look at this example. So once again, we're choosing our starting lineup. Suppose that you are a basketball coach, you have 12 players, and you need to select 5 players to start the game. We're going to go ahead and start our fundamental principle of counting by drawing all 5 boxes. And we're going to figure out how many different options there are for our starting lineup. So we're going to start by drawing our boxes. We have player 1, player 2, player 3, player 4, and player 5. Now we need to go back into each of our boxes and fill in how many choices we have for each player. So how many choices do I have for my first player? Well, I have 12 players, so I have 12 options or 12 choices for my first player. Now, how many choices do I now have for my second player? So I've already chosen one player, so I have 11 players left to choose from. Then for player 3, I have 10 choices. For player 4, I have 9 choices. And for player 5, I have 8 choices. Now the fundamental principle of counting says that now I just need to multiply these numbers together, and that'll tell me how many different options there are for our starting lineup. So 12 times 11 times 10 times 9 times 8 is 95,040 options. So there are 95,040 options for our starting lineup. Our last example leads me into talking about factorials, and I'll tell you why that is in just a few minutes. Factorials are going to make up most of your homework assignment, so it's really important that you pay close attention to this part of the video. Combinatorics often involve products of the type 6 times 5 times 4 times 3 times 2 times 1. If you multiply that all out, that's equal to 720. And what I mean by products of this type, it's where you have a number and you're multiplying out, and each time you're going to go down by 1. Right, so it could be like 3 times 2 times 1, or 7 times 6 times 5 times 4 times 3 times 2 times 1. So combinatorics often involve products of this type. This type of product is called a factorial, and instead of writing that all out, because that's really long, and you can imagine how long it would get, imagine if you were doing something like, 100 times 99 times 98, and then all the way down to 1. So that would be way too long to write out. So we have some shorthand notation to write out factorials. So products of the type 6 times 5 times 4 times 3 times 2 times 1 is written as 6 with a little exclamation point. And this is read as 6 factorial. Okay, so if you see something like 6 factorial, you know that that's 6 times 5 times 4 times 3 times 2 times 1. Now, like I said, imagine if you had something like 100 factorial. That would be a lot for you to type out in your calculator. And so as a result, our calculators have a built-in factorial button. So go ahead, you may need to pause the video right now and go find your calculator. Alright, so if you've got your calculator, you can go ahead and start looking around for your factorial button. I'm going to go through a lot of the common calculators that I find that people in my class have, and I'm going to show you where the factorial button is on all of them. But in the meantime, I also need to give you a formal definition of a factorial. It says, if n is a positive integer, integer just means a whole number like 1, 2, 3, 4, 5. Right, so if n is a positive integer, then n factorial, denoted by n with a little exclamation point, is the product of all possible integers, of all positive integers less than or equal to n. So n factorial is equal to n times n minus 1 times n minus 2 times all the way down to 2 times 1. And very important here, I don't think you'll have any problems that use this fact, but this is just kind of an interesting fact for here, or for you. As a special case, we define 0 factorial to be 1. All right, so as a special case, 0 factorial is equal to 1. Now, let me explain to you really quick why that last example that we did reminded me of a factorial. So here, when we were choosing a starting lineup, remember we did 12 times 11 times 10 times 9 times 8. That calculation was similar to a factorial, but we didn't multiply all the way down to 1. And this has a special name. It's called a truncated factorial. All right, so it's called a truncated factorial. So I just wanted to tell you why that last problem reminded me of a factorial. All right, now let's look at some examples that are similar to, actually, that I took them straight off of your homework. So this is exactly what your homework is going to look like. Oh, shoot, sorry. First, I need to show you where the factorial button is on your calculator. All right, then we'll do some examples. Okay, so let's find the factorial button on your calculator. This is a Casio calculator. It's not a graphing calculator. So if you have the Casio graphing calculator, I think the steps are a little bit different. And also, if I don't go through your calculator here, all you have to do is just type in on Google the name of your calculator. Like this one, for example, is Casio FX83 GT Plus. So you just type in the name of your calculator and then type in factorial button, and it will come up and show you where the factorial button is. All right, but if you have this calculator, let me show you where the factorial button is. This one, for some reason, people can never find it on this one. All right, so if you look at the very top, right here, there's your factorial button. So what you'll do is you'll type in the number first. So you'll type in, say, 6, and then you'll hit that factorial button, and then it'll calculate 6 factorial for you. Here's another calculator. This is actually the calculator that I recommend that you get. This is one of my favorite calculators. So if you have this calculator, let me show you where the factorial button is. Oh, also, it's in the same place if you have this calculator. This is a TI-30X. The last one was a TI-30XS multi-view. The only difference is that here you can only see one line that you're typing in. All right, but if you have either one of these calculators, here's where the factorial button is. All right, you're going to look for the button that says PRB. That means probability. All right, PRB. So it's right there if you have the TI-XS multi-view, and then it's right here if you have the TI-30X. All right, so you're going to press that button, PRB. And then you'll see 3 choices. So you'll see NPR, NCR, and then you'll see your little factorial. All right, so you'll scroll using your arrow buttons. If you have the TI-30XS multi-view, you have to use the down arrow. If you have the TI-30X, you'll use the right arrow, and you'll go over to the factorial button. But like I said before on that last calculator, you need to type in the number first. All right, so if you're doing 5 factorial, you need to type in 5, then hit the PRB button, and then hit the factorial button. All right, so always type in your number before you look for the factorial button. And then last one I'm going to go through is this graphing calculator. I find that a lot of people have these. If you recently graduated from high school, a lot of time people have this graphing calculator. All right, so if you have this calculator, it's very similar to what we just did, but there's one extra step. So you're going to click on this math button right here. All right, so click on the button that says math. It's right under alpha. And then that's going to bring you up to this list where you have 4 columns: math, NUM, CPX, and PRB. So you have the math button. The next one stands for numbers. And then the next one stands for complex. And then the next one stands for probability. You're going to click on the PRB, or you're going to, scroll over to PRB. And then when you get there, you can see that your factorial is option number 4. And just like I said last time, make sure you type in your number first, and then you look for the factorial button. So the factorial has to go after the number. All right, so if you're doing 5 factorial, you got to put 5 and then factorial. If you do the factorial first and then 5, it's not going to work. Here we go. Finally, we get to some examples. All right, so find the indicated value. We have part A is 3 factorial, and then part B is 6 factorial times 4 factorial. Some of you may have these exact same problems on your homework. So if you want to pause the video and then open up your homework, you could check and see what your problems look like. Now you can totally do these by hand. You don't have to use that factorial button, but it's probably just going to save you some time if you use the factorial button on your calculator. All right, so 3 factorial. If you do this on your calculator, I would give you a second, pause the video, and then you can figure out what you get. Or this is an easy one, you can do this in your head. That's going to be 3 times 2 times 1, which is 6. Our next example is much longer, so this is one you might want to do using the factorial buttons in your calculator. All right, so you have 6 factorial times 4 factorial. Now, we have a couple of options for what you can do here. You could separate this and calculate 6 factorial first, and then plug in what it is. I just happen to know, since we just did this on another slide, that 6 factorial is 720. All right. And then you could multiply that times 4 factorial. You could find that separately. 4 factorial is pretty easy to find. That's 4 times 3 times 2 times 1. So that's going to be 24. So then you could do it this way, or you could type this all in your calculator at one time. You could type in 6 factorial times 4 factorial, and it's going to come up with your correct answer. All right, 6 factorial times 4 factorial is 17,280. All right, that seems like a really big number, but that is actually right. I just checked it. All right, now we have some that are a little bit more complicated. Part C, we have 9 factorial divided by 5 factorial. And then in part D, even more complicated, 7 factorial divided by 2 factorial times 5 factorial. Okay, so these are definitely ones that I would suggest that you use the factorial button on your calculator for. It's just going to save you a ton of time. All right, so this one's really easy. You're going to type it in exactly how it appears here. So 9 factorial, and then you're going to find wherever your divided button is. So 9 factorial and then divided by 5 factorial. You don't need any extra parentheses here. All right, so if you take a second and type that in, you can pause the video if you want to take a second and type that in. All right, so if you've typed that in, the answer is 3,024. And then our last factorial example, 7 factorial divided by 2 factorial times 5 factorial. Now this is one where you will need extra parentheses. I'm going to draw in where you need the extra set of parentheses, so right here and right here. So you need parentheses around the denominator. Very, very important. If you ever have more than one thing going on in the denominator, it's a good idea to put parentheses around it. So like in part C, we only had one thing going on in the denominator. Parentheses not required. You can put parentheses around the denominator, but it's not necessary. Here it is very important that you put parentheses around the denominator. That lets your calculator know that all of this stuff goes in the denominator. Otherwise, what they're going to think is that just the 2 goes in the denominator and that the 5 is on the outside, okay? So make sure you put parentheses around there. Let your calculator know that all of that stuff is in the bottom. All right, but if you've typed that in, you'll know that that's 21. All right, I have one last example that I want to go through. It's a little bit challenging, but I thought this was a pretty cool example. It says, and you're not going to have any like this on the homework or on the test. So if you don't care to watch this part of the video, that's okay. I just wanted to show you how we could use, sampling with replacement, without replacement, in an example. So it says a serial number consists of 2 consonants followed by 3 non-zero digits followed by a vowel, A, E, I, O, or U. So they're not considering Y a vowel here. For example, here's some possible serial numbers. ST423E. So you see it's 2 consonants followed by 3 non-zero digits followed by a vowel. Or you could also have the serial number DD555E. So again, 2 consonants followed by 3 non-zero digits followed by a vowel. Determine how many serial numbers are possible giving the following conditions. All right, part A is letters and digits cannot be repeated in the same serial number, and part B is letters and digits can be repeated in the same serial number. We're going to go through part A. I'm going to use the fundamental principle of counting just like we did before. I'm going to start by drawing my boxes. Here's my box for my first consonant, my second consonant, and then my first non-zero digit, my second non-zero digit, and my third non-zero digit, and then my last box is for my vowel. Alright, now I just need to go back in and fill in the boxes with how many choices that I have for each letter or number. Alright, how many choices do I have for my first consonant? Alright, well, here's how I reasoned this. I know that there's 26 letters in the alphabet, and then they told me that 5 of them, these 5 right here, 5 of them are vowels. So 26 minus 5 is 21. Alright, so I have 21 choices for my first consonant. Now here in this example, the digits and letters cannot be repeated. Alright, so once I've chosen my first consonant, if I can't repeat the letters, then I now have 20 choices for my second consonant. Alright, now we're moving on to non-zero digits. Alright, so how many choices do I have for my first non-zero digit? Alright, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are my options for what I can put there. So I have 9 options. For my second non-zero digit, since I can't repeat the numbers, I now have 8 choices or options. For my third non-zero digit, since I can't repeat the numbers, I now have 7 choices or options. And then for my vowel, they told me that there's 5 vowels. So the last thing I need to do is multiply these all out. 21 times 20 times 9 times 7, 9 times 8 times 7 times 5 is equal to 1,058,400. So that's how many options there are for serial numbers if letters and digits cannot be repeated. So here's my answer. Alright, part B, very similar, so I'm going to go through it quickly, but this is where we can repeat digits and letters. Alright, so just like before, I'm going to start by writing or drawing all of my boxes. For my first consonant, just like before, there's 26 letters in the alphabet. They told us 5 of them are vowels, so there's 21 options. Since I can repeat my letters, I'm going to still have 21 options because I could just repeat the same letter from the first consonant. For my first non-zero digit, just like before, I have 9 options. Now for my second and third non-zero digits, I'm still going to have 9 options because I can repeat the numbers. And then for my vowel, just like before, I have 5 options or choices. Now I'm going to multiply these all out. 21 times 21 times 9 times 9 times 9 times 5. That's equal to 1,607,445. So quite a few more than part A. So if you can repeat the letters and digits in the same serial number, then that's how many options or choices that you have. Or that's how many possible serial numbers there are.